Alright, I'm back. We're here with part 3. We'll talk about this mess in a minute, but I just got in some parts today, and as you can see, I got in some new electrolytic can capacitors for my ICO ST70, and I bought some nice Solon high quality capacitors for the coupling caps in this ST70, as you can see. And I got some of these Sprague atom type capacitors. So all good stuff. And I picked up some, while I was at it, some extra stereo potentiometers. I was running low on those. So that stuff came in. I got in my new 12AX7s for the ST70 and the 6SN7s and the GZ34. However, this one I'm just going to keep as a spare because the one that came with the ST70 is in good shape, so it's good. I am still waiting for the 7591s. They're a matched quad, and they were not in stock, so they're on back order. I'm hoping to have those shortly. And I ordered from another vendor. I ordered a whole bunch of resistors for a bunch of different projects. I'm still waiting for those to come in. They should be in maybe tomorrow, maybe the day after, not sure. Now, to this mess. So, when we look at the schematic here, and we look at the color code down here, resistor code. Alright, y'all see that? Resistor code. Arr, keep to the code. Okay, never mind. So, if you look here, the dark blue is a 2 mega ohm resistor, 2 meg. Lavender, or I'm sorry, lavender dark blue. Okay, I guess they didn't know what you would call it, so they called it both, is a 2 meg. And the small green resistor is 0.5 meg, which by today's standard would be a 470K resistor, but anyhow. You go up to the schematic, and there is no 2 meg resistor. There is no 5.5 meg. There's just these two here that says 2 ohm and 5.5, and there was a dot there, but it's hard to see. I wrote in meg, but to me that says 2 ohms. So I'm looking all over this thing, looking for these resistors that are obviously in the actual radio. You know, it's like, Mr. Noodle, it's right there. Well, I didn't see it. So finally I figured out, once again, when they put the actual ohm sign, that means mega ohms. Now, in other old schematics from the 30s, they actually put 2 meg, M-E-G. They put 30 M, and then that little W looking thing for 30K, M meaning, millennia, M, the uppercase M is the Roman numeral for 1,000. So 30,000 or 30K. But boy, I'll tell you, it is hard on these old schematics to follow whatever it is the heck they're talking about. So, the other thing is they show these goofy 5 ohm and 25 ohm. And so, does that mean 5 meg and 25 meg? I don't know. Because if you look at this, this is your center tap. And normally on these radios, your center tap goes to ground. And if you look, now they're not showing a jump over. See how they show it? Like if you're crossing over, they put that little bump. This is not a bump, so I'm assuming this is tied in here. So you have this going to ground, which doesn't make any sense. Okay, never mind. I see what they're doing. So they're coming out of, I'm sorry, this is a tube rectifier. So this is your positive right here, up here, which is right. This should be the ground. But if you look at how this is tied in here, this part's right. But if you look at the field coil right here, this field coil, according to this, is tied to ground on both sides. So what's up with this? And I do think they mean 5 ohm and 25 ohm, because these, I believe, are the resistors that are contained in this condenser can, which has all of these in there. And you can see how many connections. There would be a connection here, connection here, connection here, connection here, connection here. And so you can see 1, 2, 3, 4, 5, 6, 7, 8 wires. So if this wasn't so tightly soldered together all the way around, I would open it up and look inside. But that would be some destructive testing, if you know what I mean, to get in there. So, wow. So we got our positive line. This part here makes absolutely no sense, what they're talking about. Again, I don't really understand. This is the field coil of the speaker. And I don't understand why you would shunt a 30 ohm load across the field coil, which this field coil's, up over, upwards of 1,000 ohms or more. So why you would shunt this, I have no idea. My gut feeling is either A, this is actually supposed to be a crossover here. And I'm going to have to really think about this, because I've really just haven't looked at it until now. So, would this be something like that? I don't know. In that case, you would have a 5 ohm and a 20, so you'd have about a 30 ohm load to ground on this. Now, 30 ohms to ground, I could see that. And the reason they're doing this is they're creating, looks like they're creating a little bit of a bias voltage for this grid. So they're floating this 25 ohms above ground, which is going to put a little voltage here. That voltage in turn is going to go over here onto this 2 meg resistor, and it is going to put a little bit of bias, but limit the current to almost nothing, onto the grid of the 45 tube. And that's how they're biasing the tube. Because once again, the filaments on this is a direct heated tube, they call it. In other words, there is no cathode plate in there. There's just the filament. The filament is the cathode. So this is an old way of doing a fixed bias. Any of you that work on guitar amps will know what I'm talking about. That's what I think is going on here. Again, I am not a master of these really old antique radios, so I know some of them, but this really old stuff can sometimes be pretty confusing. But that being said, again, you're still putting an 8 microfarad capacitor from the positive to the positive end of the field coil, and I don't see how that's going to work. I just don't see how that's going to work. That's going to block the DC. So again, looking at this, None of this is making any sense. I think it is drawn incorrectly. So I'm going to try to look through a couple other schematics that I have of some of the older models of this radio and see if there's something that makes a little more sense. And after I do that, I'm going to come back and hopefully have some explanations for you, because right now Tony's pretty confused. So maybe some of you see it, but nope, not me. So I'll be back. Okay, so here we go again. Jackson Bell Model 62. Jackson Bell Model 62. And this says second and third series. Now, they're very similar, except, take a look at this. It makes a little more sense what they're doing right now. Okay, so, if you look here, in this manner, you've got your center tap going to ground the way it should. That's what I'm used to seeing. You have your filament, the center tap of your filament, going to your B+. So this is B+ right here. You have this going to your field coil and your first capacitor, which is a 2 microfarad. Okay? And you go through your field coil, so your field coil becomes the choke, all right, and goes into this 4 microfarad. Okay? So right here is your actual B+, your filtered B+, that's going to go into your output transformer and then go over to your different voltage taps. Now these tap off your lower voltages for your receiver tubes. Okay? This is all making a lot more sense. Very, very much better drawing than this one. And this looks more, now this 45, again, like I said, see what they did? They took a resistor, 2200 ohm, 2.2K, and they're floating the ground, and they're also putting this capacitor across here. I'm thinking that's a 1 microfarad. It's hard to read, very hard to read. But this makes sense, because now what you're doing is you're putting a little bit of cathode bias through the center tap, and you're putting a little bit of a bypass capacitor, that 1 microfarad, to add volume. So this kind of boosts the volume and boosts the bass. That makes sense. Then they drew it out properly now. It, as I thought, it is a 2 meg resistor, and they're showing 2 million, and then the little ohm symbol, and 500,000, the little ohm symbol. So right there is that. Now, strangely enough, our little friend, the coil, the choke coil, seems to be right here. I'm assuming that's what this is. So maybe this actually really belongs to this radio. I don't know. And looking at it, I can see some of the original wires that were cut off of it, where I cut them off. They look like they may have belonged on there. I don't know. But that's making more sense. This 2 mega ohm resistor is going to ground now, and you're grounding your grid. That's your grid leak resistor. Okay? Now I know some of you who are really into tubes, that's not really the purpose of, they don't call it, it's not leaking the grid, but what this does is this gives a very small amount of current, keeps it on the grid, so that the grid doesn't float away on you and mess up your bias. So anyhow, grid leak resistor, that's what we call it. And there's your coupling capacitor, 0.02 microfarad. Here's your another 8 microfarad. Okay, so what you're doing is this coil and this capacitor from here and here is actually acting like another. So this is one pi network for filtering DC. This is another pi network for filtering DC through this 500K up to your detector. This is kind of like your detector circuit. So in other words, you have first RF, second RF, third RF, and then your detection. Okay, so, or fourth RF as they call it, but that's also going to be kind of like your detector that's going to pick off your audio, which gets coupled through this coil into the grid of the 45 output tube. So that's a type 45, and these are your 24s right here. So I think we got a more anatomically correct schematic here. So this one, I like the little chassis layout, and I like the color codes that's in this one. That's good, but this part here is messed up. It is not drawn correctly, and they made a mistake on it. I mean, it's a typo. There's no possible way this could have worked like this. This is how it should have been drawn. So this is the schematic we're going to use. Now that we got that out of the way, and I know I'm not crazy now, we can kind of tackle this a little more. Now, still, and that also makes more sense that this transformer that's in here still may be the wrong one. I'm still not convinced that it is the correct transformer. 450 volts DC here just still seems way too high. Even going through all these coils and all this stuff, I don't know. Of course, these are some big resistors here, you know, 5K and then 10K, 10K, 10K. So maybe that is a good voltage, a good B+. All we can do is go ahead and rewire it the way it was. Make it wire up like this. If this ends up being too much voltage right here, then we'll break this wire right here and we'll put a dropping resistor. And we can do that. Okay, we'll just have to put another little capacitor here. You know, again, we'll have another little pi circuit, pi filter. We can do that, maybe 1 microfarad or something. It doesn't have to be much. So that's where I'm at right now, and I'm sure glad I figured that out, because that other one was just driving me batty trying to figure it out. The other thing that they are not showing in here is you have a voice coil right here, but you also have another coil wound in here, right around here, and it loops in with this, and what it is it's like an anti-hum coil. Okay, it's actually in series with this. Like part of it, one of it goes here, and then the other wire goes up here, and it is wound opposite of this coil. And it's basically, what it does is it suppresses the hum. Okay, it's just a little, maybe about 20-30 turns of wire right on the center pole of the speaker, where that this is wrapped around to make the magnet, and it's in there. So they're not showing that, but it's in there. It is in there, and it does use it. So that's a very common thing in these really old radios. So I'll show you some of that. Maybe I should have showed you that when I was rebuilding that speaker, because I had it out and put it back in. But anyhow, choke coil goes back in. We need some 8 microfarad. Well, we need an 8, a 4, and a 2. So we need 3 capacitors, and fortunately those are so teeny tiny today compared to those big old ones that we can actually just kind of find some space inside the chassis to mount them in there. That shouldn't be a problem. And I've got these, I'm sure I've got all these in stock. So, all right. Little by little, we're conquering this thing. So, let me get back to what I was originally doing now that I understand what's going on and have a good schematic. I'm going to take this out. I already started. I took this first screw out. I got to take this other one out. There's another coil down here that's on a wooden form. And I am thinking that it is this one right here that we're looking at. I'm almost positive that's what it is. And this 0.0025, well, looks like somebody just put in what they had, because now again, if you look at this capacitor here, that's a 0.047, and that's going from the 2 meg on one side, right there, to the junction of the coil and the 500K, which is, here's the junction of the coil and the 500K. So that's that is the absolute wrong value. So I'm going to replace that with a 0.022. What that's going to do is that technically could let a little more bass through, but in another thing it can also cause it to maybe oscillate by allowing too much signal through. I'm not sure. That may not be really critical, but I'm going to put the one in that they're calling for. We can always experiment later. I can shunt another 0.022 across there to simulate a 0.044, which would be like this, and if it sounds better, I'll put this back in. This one here, that's this one, and you can see how ancient old that is. This is, you won't see these anymore. You know, you hear about the old wax and foil capacitors, which, give me a second. So, if you look here, this is an original wax and foil capacitor. It's a leaky one, but I just kind of keep it as an example. And this is a more modern, antiquated capacitor that they don't make anymore. These had a lot of problems just like these, but they tried to improve on this design by taking this, putting a cardboard tube over it, and then coating it with beeswax. That's what this is. This is just beeswax. You can see it like flakes right off. And these failed. So and these were from like the late 30s, early 40s they started, and they've used these all the way up into maybe the 50s, maybe even the 60s. And this is the predecessor to that. This is what's inside of this without the cardboard tube and the wax. So you can imagine how quickly these failed. So that's got to go, and there's 3 more underneath that I have to lift this up and take out. This is a 0.22 microfarad down here, and that is supposed to be the tone control capacitor down here, for our tone control here. So, and you can see the wire kind of bodged in with tape. We got to get rid of that. So I'm going to get a more appropriate capacitor for there and get that fixed. So starting to figure it out a little bit at a time. So all right, let's get some things replaced and then I'll be back. Yep, I would say those capacitors are no longer any good. You see all the schmutz, yuck, coming off of them. So yep, we'll get rid of those and replace them with the correct ones. Alright, isn't that much better? So we got the new capacitors in there. That 1 microfarad that was connected inside that can, I believe, has now been replaced by this teensy weensy little one here, which will be just fine. It looks kind of hack job in there, but it's actually good. I'll probably hot glue that down before I'm done. Got all the wires repaired in here. You can see all cleaned up. All the soldering is cleaned up. I put the proper size of capacitor. I removed this 0.047, went to a 0.022. So I'm ready to reassemble this. I got one last thing to do. I got to fix this tone control pot and fix this, and then we're going to be moving on. So looking good. Okay, do you want to see something really amazing? In front of you, you will see basically a 250 picofarad capacitor that is upwards of 80 years old. And, well, it is 80 years old. And I just want to show you here, this is a very expensive piece of test equipment to test capacitors. And I want you to look at the value. It is 190 picofarads. It's a little bit low, but look how bad that thing is. And look at the leakage. No leakage. I can go up to 100 volts. No leakage. Isn't that amazing? Do you think any of the components that we're putting in today will be that good and last that long? Amazing. Just amazing. Just thought you'd all like to see that. Alright, so this part of the amp is officially, or with the radio is officially done. We got a little more period correct tone capacitor. I actually have a few of these new old stock that I had. They test out zero leakage and they test out the correct. These are 0.27 microfarads. This one's coming out right around 0.26, 0.25. So it's right where we want it to be. This one's changed out. I have the tone pot hooked up. I got the new, I put a silver mica capacitor in here. Take the place of that one that actually still read good. And here's our filter capacitors. So we have 1, we have 2, we have 3, and I believe there is a 4th one somewhere. No, maybe not. Nope, there's just 3, that's all. So those are all connected. We have the coil, choke coil installed back in. I did use terminal strips and I turned the coil 180 degrees back because the terminals on top of there were so brittle and broken. I was afraid that they were going to fail if I didn't do something like that. So everything's connected, and we're ready to start moving to the other side of the radio. I have one more capacitor to replace, and then I have to tackle the transformer, which is going to be the toughest one, and this pot, which I think I know what I'm going to do. I hope I have the part that I need. I think I have it, but I'm not sure. But we'll have to wait and see. Anyhow, that's where we're at. Okay, little update here. I got this 0.1 replaced, and this old Cornell cap that was in here, it actually was bad. It leaked really bad, and it was reading about 0.2, and it's supposed to be a 0.1. But that still was pretty cool that that one was still reading good. So I cleaned up this wire bundle here, and most importantly, I replaced this pot. Now I went with a 5K instead of a 3K, and I swapped out those big resistors for these ones, equal value, and I rerouted these wires in such a way hopefully they won't interfere and cause any kind of hum or oscillation. And that leaves this whole opening in here to hopefully fit that transformer in there. Once we get that mounted, we're going to be ready for power. So, alright, we're on the final stretch. Okay, so let's do the little nickel tour before we start this up. We're ready for a smoke test, and I've got my meter hooked up, as you can see, to one of the capacitors for the power supply. And if we look at our schematic, I'm looking right at this area right here, right where the B plus is coming out of the 80 tube. Now I have the 80 rectifier plugged in back there. I have no other tubes plugged in, so I'm only plugging in the 80 rectifier. And we're going to see if we get some voltage at this point right here, which I want that to stay under 250 volts. If we get anything over 250 volts, that's going to be too high, and I'm going to be a little bit nervous about that. Now, I went really overkill on trying to protect this because I think this transformer, again, is a little bit overpowered. So one other thing I did, if you notice right here, I installed a CL90, and that's an inrush current limiting device. Basically what it does is it starts out at about 150 ohms, and it puts a load right on the primary of the transformer. So it's actually, basically, if you break the wire right here and put it in there, that's where it is. And what it's going to do is, as soon as current starts flowing through it, it heats up. As it heats up, the resistance drops on it. So basically what it's doing is it's protecting the transformer, and it's protecting the capacitors, and it's protecting the power tube. So on old gear, sometimes that's a good idea to do because that's going to protect, everything from overload. The other thing is I'm just trying to limit the voltage a little bit and drop it a little bit because we don't want to exceed our voltage. Now the other thing is, when I fitted the capacitors, there's basically three in here. You have your pi circuit, which is here and here. That used to be a 2 microfarad and a 4 microfarad, and then they put an 8 microfarad up here. I changed them all to 10s. Why did I do that? Well, first of all, on an 80 rectifier, a 10 microfarad capacitor should be okay. I don't think it's going to overload this, especially with that inrush current limiter. Second of all, that's going to make it a little bit quieter. And third of all, the other 10s that are on either side of these choke coils are going to be current limited by the coils. That's what these choke coils do. So I'm basically going to just look at this part of it and this part of it. I don't have the speaker plugged in yet. I don't have a 45 tube, so I can't even test that. But what I can do is make sure we have power here and here. And that's what we're going to look at. So that's where we are. Okay, so let's back this up. And what I'm going to do is I'm going to turn on my variac. Now this is an isolated variac power supply. And I have it set, if you look right up here, I have it set to look at amps. So it's on the 0 to 2 amp scale. I'm going to be monitoring the current on this. There's also a 1.5 amp fuse in here. So we're just going to watch, and basically what we want to see is if our 80 rectifier comes up and if we get some kind of voltage. The other thing I did was, if you look right here, this is the output of this choke coil. I put a 10K load, about 10,000 ohms, 25 watts of resistors in there. So 4.7K. So that's approximately 10K. And I'm just doing that because I want to load the circuit down a little bit so it'll show kind of what the voltage is going to settle to when you have the tubes actually in there. So that's what we're going to measure, and let's see what we get. So right now I'm just going to bring the voltage up to about 25-30 volts right now. Pretty soon we should see my meter shut off. Turn on. Okay. And until the filament gets hot enough on the tube, it's not going to conduct. So that's the other thing. We have to kind of just bring this up a little bit at a time. We getting anything here? Oh, well, it would help if I plugged the thing in. You see that, guys? I'm not editing this out. Okay? Alright, now that it's plugged in, because the electrons have a really hard time jumping out of that outlet and jumping into the prongs of the plug. So let's try this again. About 30-40 volts we're going to put in here right now. Okay, I'm drawing very minimal current at the moment. But there is a little bit of current draw. Not enough to heat the tube though yet. So let's bring it up to about 45 volts or so. I'm drawing a little more current, and there we go. Now we're starting to climb. The tube is just barely starting to heat up now. All right. Okay, let's go to about 50, 60 volts here. That did it. Now the tube's working. And you can see we're only getting about 6 or 7 volts because the rectifier tube is not heated up enough. Okay, so let's go about 75 volts. Just taking its time. And that's what we want it to do. Alright, I'm going to go to about 90 volts. Now you're starting to see the tube starting to do its job. So far so good. I'm not feeling any heat coming off of these. Well, let's go up. I got 120 on there now. Whoop. Looks like we popped a fuse or something. What did we pop? Did the fuse open up? Doesn't look like it. Maybe it did. Let's go back up. Yeah, I think we opened the fuse up. Okay. So, still something going on here. Did we let the fuse go? I'm going to shut this off. I'm going to unplug it. It's not showing any voltage, but we still never take chances. Remember, you can have quite a bit of power in there. This transformer has 800 volts or more between, on the secondary. So you always want to take your stinger cable, and I showed you guys on another video how to make one of these. And you want to go through all of your capacitors, make sure they're discharged before you reach in there. Okay, so let's take a look at our fuse for starters. Yep, our fuse is opened up. So we obviously drew more than an amp. Now I don't know, I don't think we should have drawn that much current, but you never know. All right. So let's go back in here again, and we're going to try it again. But at least for our first power up, we know that that it's wired correctly. We know that the 80 rectifier is working. We know that we can get about 225 volts at full power, and we also know that when that thing started to go, it opened up that fuse. Now what I don't know is it just because I had a fast acting 1 amp fuse, or 1.5, what is that? Yeah, it's a 1.5 amp fuse, and that might just be a little bit too low for that for this thing to be. I don't even know what size fuse this was supposed to have to begin with. And remember, this is not the correct transformer. I did make up a bracket to connect it in there, but it's still not perfect. So okay, so this was a good start, and once again I think I'm going to end this video right here, and when we come back I'm going to have to get some tubes, and I'm going to have to do a little more experimenting with the power. But as you can see, we got this all wired up. By the way, I really didn't pay much attention, but if you all look down here, let's see if I can pick this up. It's upside down, but let me zoom you in. There is actually a really hard to read grungy schematic on there that I really didn't notice. I mean, I just really didn't pay a whole lot of attention to it back there. but it is a schematic, and I just kind of compared it, and this second schematic that I found that we've been working off of is actually exactly the same as what's on the back of this chassis. So we do have the right circuit here. By the way, this was missing. This resistor and capacitor combination was missing from the radio. I added them off of that center tap, and you can see it right here where I added it. Right here's the resistor and the capacitor, and that's very important because that's how the 45 rectifier finds its ground. Remember, this is a direct heated tube, meaning the filament is the cathode, and therefore the only path to ground, so you could have a path to ground from your plate to your cathode, is through this winding here, and they take the center tap of the winding and they ground it. Now, on some of the older ones, they're grounding that rectifier directly, but in this particular iteration and on that little schematic on the back of the chassis, they're actually putting this little biasing resistor of 2200 ohms in a 1 microfarad capacitor. Okay, and that's another thing I noticed. There's a 1 point. I put a 0.1, so I'm going to have to change that out too and swap it for a 1 microfarad. So once again, and that might be that thing that was up on that tag board up there. I'm not sure. I'm going to have to look at that a little more. But anyhow, we did get some voltage out of this. We did mostly finish up the wiring. So next video, we're going to start looking at a little more, putting some tubes in it and seeing what kind of voltages we get on our tubes, and see if they'll bias up, see if our oscillator, well, there is no oscillator, but see if we can get some RF to go through them, and we'll continue from there. So anyhow, this is video number 3. Give me a thumbs up if you think we're doing good here. Like I said, this thing was a real basket case when I got it, so this is definitely not my best work, but with what I had to work with, this is the best I can do. And man, if we can get this thing to play, that'll be really cool, because this was a real challenge. So alright, until next video, have a great day, and more to come.